Fine. So till now, we have seen the introduction to the steel structures, and we have also observed that there are few uh, uh, structures those are exclusively made up of steel, and we also studied the relevant Indian Standard Code. We also saw that there were revisions which were made, and what necessitates the uh, revision part. There may be some addition, there may be few research based on which these revisions are made. So you can see the first IS 800, which was introduced in 1956, then was revised in 1962, then in 1984, and the latest version is 2007. The major changes were also made known to you people. Slowly we will go into the details of the major changes, whatever are written over here. And we saw there are different types of structural steel, those are there present. So it confirms all the structural steels, they confirm IS 2062 2006. Now there is one more version which is 2011. Uh, there is slight change as far as the terminologies for different grades of steels are concerned. So we will also see to it. Then, one minute. Now we wait for a while. Something has happened. It is not moving ahead. One minute. Now we are stuck. Please hold on. One minute. Am I audible to all?
Yes, sir.
Okay. Yeah. Huh. We also saw the manufacturing process of steel, and the main component, as you can see, it comprises of iron ore. Steel is an output of iron, and somewhere you will find the reference of this iron whenever you will speak in terms of the grade of the steel. You will see to it. But this is a overall manufacturing process of iron, and the output results are, it may be in the form of thick slabs or thin slabs in this form, just like thick or thin plates, you can say. Then these are known as blooms and billets. Now, after we get the output, which is still in the hot form, as you can see, the color of these things, slabs and the blooms and the billets, the color is orange red. That means they are still hot, right? And after this, as far as the structural steel is concerned, you must have observed the pictures which I had shown to you. In those pictures, you must have observed there are different shapes associated to the steel structure member. For example, someone told me about the eye, eye type of cross section, right? So similarly, you will find there are different cross sections associated to steel, and this output, what it looks like, it is just like a thin plate or thick plate. Here also you will find that it is a rod type of thing. Now these rods or these thin plates and slabs or thick plates and slabs, they are then given different shapes, right? So there are two different processes associated for giving shapes to these output result of the manufacturing process of steel. So what are these? These are hot rolled sections and cold rolled sections or cold form sections, right? So usually the structural steel which is available with us, it is, अरे क्या हो गया? What happened? Some issue. Okay. Is it visible now?
Yes, sir.
Okay. So the steel, whatever members or whatever structures I have shown you in the picture, those are hot rolled type of sections. Hot rolled type means it is a process which is followed after the formation of these outputs. What is done in hot rolling, as you can see, the thin slabs or thick slabs or billets and blooms, these are actually still hot. And in this state itself, different shapes are given or they are provided with the help of different molds. So what are these molds? You can see over here. Okay, with the help of such type of molds, different cross sections are shaped. As you can see, this mold provides a eye section, as you can see over here. And similarly, there are different types of cross sections which are available. To name few, the C type of section, that means you will find this much portion only. Okay, this is known as C shape. Okay, then T, that means this one and this one. That's it. T, T cross section. Then there is one more thing which is known as angle section. Okay, and it is always 90-degree angle. So you will find this much portion of the steel from here to here. That's it. Okay. So such type of cross sections can be prepared or can be molded with the help of these molds, as you can see in this picture. Okay, and this process is carried out when the steel is still hot. Okay, so that process is known as hot rolling process. In case of cold roll, this all these things are allowed to cool, and after that shapes are given. So it's a different process altogether. And as you can see over here itself, if this is in its semi-solid state, it becomes easy for anyone to give such kind of shapes, isn't it? But if this becomes solidified, in that case extra workmanship is required to give such kind of shapes, right? But the process of cold forming or cold rolled sections, uh, that is quite, first of all, it is expensive because we need to give a shape for to a cold billet or bloom or slab, whatever it may be, right? So it's an expensive process. Secondly, the output of that cold forming or cold rolled section, it is quite good. The shapes and all are perfect. There is no uh, distortion as far as cross section is concerned. However, in case of hot rolled sections, these are quite, I mean, compared to the cold rolled sections, they are quite easy to form, firstly. Secondly, uh, they are not that expensive in nature since the formation is quite easy. And thirdly, there may be distortion that may be observed in the cross sections. Reason, because as you can see, this is still in the hot state. And then, sorry, after giving a shape, particular shape to this mold, what will happen? It is allowed to cool. All of a sudden, it is allowed to cool. So, because of this sudden variation in temperature, there may be certain amount of stresses those may be involved in it. Those are known as residual stresses. Okay, because of the sudden variation in temperature, sudden cooling effect will develop some amount of inbuilt stresses. Those may be useful or they may be harmful in the long run of the complete structure. Those are known as residual stresses. Sometimes residual stresses are useful, but most of the times they may be harmful. Okay, that we will see. But just try to understand that because of the variation of the temperature, some stresses are developed, and by the virtue of those stresses, there may be a possibility that some distortions are developed in the overall cross section of the member, right? So, based on that, you can see the classification of hot rolled and cold rolled steel sections are. If we talk about hot rolled section, it is easier to make, easy to give shape and form. Billets are actually heated at 1700 Fahrenheit, and then later on they are rolled in desired shape. Further, they are cooled at room temperature, and because of this variation, less control over final shape and size is there. Because of that, warping, rough texture, and slight distortions can be observed, and they are the reason for the disadvantages of hot roll section. But owing to the this advantage, this is the advantage, easy to make shape and form. Owing to this, hot roll sections are preferred. If you compare cold roll, you can see cooled steel is processed further by breaking or cold forming to achieve desired shapes. Smooth, shiny, or accurate shapes are obtained, but it is very expensive, and because of that expensive business, very few shapes can be made, like sheets, box sections. Okay, and you will hardly find the cold form steel or steel, cold rolled steel, to be forming a main member of any structure like the column and beam. Okay, you will never find. ठीक है, जिसके पास बहुत पैसा है, those can afford, but it is not recommended. Okay, then these are the shapes of the steel sections which I was discussing about. So you can see this is a T bar. This is known as T bar. The cross section is like this, and this is the length of that member. This is L angle, or it is also known as angle section. Commonly, it is known as angle section. Then this is the box type of section. Okay, this is known as I section, or it is also known as wide flange. So I will let you know what this flange stands for. This is also a type of I section, but over here, this is particularly known as I beam. I will let you know the reason or the difference between these two. And this is known as the channel section. Now let us discuss about this flange. So you can see there are different components as far as this section is concerned. What are these components? Let me tell you. This is known as this horizontal member. You can say horizontal thin plate. This is known as flange. This is also known as flange. So if the orientation is like this is known as top flange. This is known as bottom flange. This vertical thin plate, as you can see over here, it is known as web, W-E-B, web, right? So wide flange, because you can see the dimension of these flanges compared to the web, this is more. So hence they are known as wide flange. Sometimes they are also known as H sections. Okay, H, like this. This is particularly known as I section because the flanges, as you can see in this figure, the dimension of the flange, that is the width, it is very less compared to the overall depth of the web. Okay? And therefore this is known as I section. As we write I anywhere, capital I, it resembles to that. So therefore it is known as I section or I beam. Uh, this is known as channel section or C type of section. Commonly it is known as channel section. Shape is C type, right? So frequently we shall be using all these members. Whenever we will speak about the design of any structure or any component, any element, so slowly you will be introduced with a new term. For member, we call that member to be an element, right? So even if I am talking about some element, just remember that I am talking about one member of a given structure. Okay? So I hope you have understood the cross sections. These are the shapes, different shapes of the steel which we will be dealing with. Frequently you will find I section, channel section and angle section. Okay? These will be used. Yeah. This is a form of, or this you can call it as the output result of cold rolled section. Okay? These are typical shapes and they are not used in the main member like the column and beam. They can be used in case of purlins. What are purlins? आप लोगों को मालूम होगा, but even though we will be discussing about the purlins in the uh, further discussion, whenever we will be talking about or we will be discussing about the uh, analysis of industrial shade. In that case, you will come across these purlins. So these shapes, which is typical Z type of shape, all these things are also available. Right. So we discussed about the shapes. Now, what are the different types of steel? Isn't it? So there must be a question in your mind that what may be the different types of steel, and out of various steels, which steel should be used for construction purpose. So the classification is in front of you. First is the mild steel, whose carbon content is up to 0.1%. These steel sections are used in buildings, bridges, etc. So you can see common utility of mild steel is in buildings, bridges. Okay, so common structures, you can expect the construction to be made from mild steel. The next category is medium carbon steel. The carbon contents, there is an increase, as you can see, as per the name of this medium carbon steel. The carbon content increases, and the increment is up to 0.25%. The purpose of making use of this carbon steel uh, is at boiler plates, structural steel, etc. So uh, mostly industrial components, those are made up of this mild, medium carbon steel. Then if the carbon content increases up to 0.45, then they are used as rails, tiers, etc. When the carbon content up to is up to 0.6%, they can be used as they can be used in hammers, etc. That is the tools you can expect, right? And the range for medium carbon steel, as you can see over here, it ranges from 0.25% to 0.6% for the carbon. Similarly, if you want to discuss about high carbon or hard steel, the percentage of carbon increases from 0.75 to 1.1. And you can see the purpose or the uh, utility of high carbon steel mostly is to prepare tools, as you can see over here. They are hard. Okay, they are hard because the carbon content is more, but the ductility is compromised. Our aim, mind well, our aim is to maintain the ductility without compromising much on the strength parameter. That may be achieved in your mild steel, right? Now, the statement which I just now made, that our steel should be such that it should be ductile in nature without compromising the strength or the capacity of that material. Mild steel is best. The reason is in front of you in the form of stress versus strain variation of mild steel. So let me open this video for you. Hope so it will work. Otherwise, I will have to copy it and paste it somewhere else. 1 minute. Huh? Hope so it will work over here. Just hold on.
Granule does more than catch air. With Granule, you can fly really good.
This is how fast YouTube is with grid. Notice how there's no pre-roll ads? And here's how you can see how much time you save with grid. Look, Chrome is great and to go.
Okay. So is this visible to all?
Yes.
Okay, so this is a specimen which is to be tested. The diameter of this specimen, this is a round mild steel bar, you can say. This is the length and this is the diameter of that, represented by T naught and L naught. This is the testing machine, and the stress versus strain variation will be represented on the screen itself. Okay. So you can see the test is commenced. In this, what is happening actually, this is the UTM, you can say. Force is applied onto this specimen. A pulling force is applied. Okay. And the variation for stress versus strain or load versus elongation, force versus elongation, that is plotted. So you can see the variation. Initially, with the increase in the elongation, the force also increases and vice versa. So the plot is there. See, it is increasing, and how is the increment? You can see it is in the linear form, isn't it? It is increasing from some 0th value, and it is going in the linear manner. And now you can see what has happened. After a certain point, this linearity is lost, and you can say with the elongation, with the further increment in the elongation, the force that reduced. Okay, you can see, right? And this will continue with the further increment in the elongation. What do you observe? It is constant. So somewhat it is constant, isn't it? Force is constant. It will continue up to one point, beyond which, with the further increment in the elongation, it goes into some non-linear variation of the force, as you can see over here. It is kind of a curve. We don't know what is the degree of that curve, but it is in a non-linear type of curve. Correct? Okay? Then further increment, what do we observe? Let us try to understand. It has increased, and you can see over here, there is one arrow which represents that there is a formation of necking, or it is also called as neck, right? Necking means the overall cross section of that portion, it reduces, right? And you will observe the typical location to be somewhere at the middle of that specimen. Fine. Then it increases. You just observe over here also, left side specimen part. You will find the cross section. It is changing, and the force is getting reduced, and a point will come that this specimen will break. You can see it failed. Okay, so this is a typical stress strain curve which is observed for mild steel. And over here, what do you observe? That more or less this is a straight line somewhat. Okay, if we modify this, it may be a straight line compared to the other dimensions of the stress strain curve. Okay, over here, even if we remove the force, the specimen, it won't come back to its original position. However, if we remove the force in this portion, then the material will come back to its original shape. That is known as elasticity and plasticity. Okay, that is the definition of that. Then the point from which the plasticity ends and some nonlinear variation starts, that is known as strain hardening process. Okay? This is a point where you will observe that the force is maximum, isn't it? This is the maximum force. So if we talk in terms of stress and strain, this point will represent the maximum stress value of that material. This is known as the breaking point, necking point. Okay? And after this is post strain hardening area, right? So this is a typical explanation for the stress strain variation of a mild steel, and this is very, very important for our study. I have shown you this video purposefully. Just try to understand the various components. This is known as yield stress or yield force. So there are two terms. This is known as lower yield, this is known as upper yield, and this is known as maximum force or stress. Okay? Earlier they have represented it with respect to force, that is now represented with the help of stress. One and the same thing, because if we want to calculate this stress value, it is nothing but force divided by this S naught value. Okay. How do we define stress in terms of force? Area will be there. Okay, that becomes the area of that specimen, right? So we can easily calculate the stress and we can easily say what is the difference between the two. Now you can observe over here. This is the broken specimen, okay, and this is the original specimen. What do you observe? Length of this original specimen at this stage has increased, okay, and we have explored the capacity of that specimen till it breaks, okay, right? If I go back and if I see this portion, ये देखो, ठीक है, यहाँ पे मैं रोकता हूँ. So you can see at this location the force is maximum or the stress is maximum. Don't you agree? That means what we are doing, we are actually allowing that material to use its full capacity, full strength to yield or deform before failure. Before failure. And up to this point where the stress is maximum, if we are in position to allow that material to use its capacity, then it is the best part. This is the advantage that is being taken in your limit state design method, LSD or LSM, whatever you call it as. This is the advantage. The material is allowed to deform up to its maximum capacity. In contrast to the working stress method में क्या है? Only up to this elastic limit. उसमें भी factor of safety लगाते हैं, and that after applying the factor of safety, the value comes out to be somewhere here. Don't you feel so? Isn't it? So, so the biggest disadvantage of working stress method is that it doesn't allow us to make the full utilization of the material up to its maximum capacity before breaking. Okay? So I will come back to this figure. Over here, as you can see, this property, which is known as ductility, it is the ability of any material to yield, to deform inelastically, or it can undergo inelastic deformation before failure. That is the capacity or ductility. And if we are in a position to explore this, then we are allowing that material to use its full capacity, full strength. We are not restricting it to the elastic limit itself, and that too by applying permissible limit. So this is the summary, you can say, for limit state design method. Okay? There are few things which we need to remember, which is known as the upper yield point, lower yield point, yielding. This is known as yielding. This is known as strain hardening zone. This is ultimate tensile strength. This is the fracture, or the point at which this specimen breaks. Right? The area under this complete curve, that is from here to here, this is known as toughness. ठीक है? So what we are actually trying to achieve? We are trying to achieve the material to have its to be tough. Okay, it should also be ductile. Okay, so that is what is our aim. The same thing has been represented over here with more clarity. Then a few chemical properties as far as the steel is concerned, that is represented over here. Uh, as per IS 2062-2006, which is still used in your IS 800-2007, that we shall be referring, and with some modification. Only the abbreviations are changed. I will be talking about this thing, that is the grade designation, and what are the different uh, grades those are available, and those are widely used for our steel structure. Okay, so these are the grade designations which are provided with some modification in 2011. These are the mechanical properties. Again, they refer to IS 2062, right? With grade designation and with some more information that I will be explaining to you. Okay. Now see, as far as mechanical properties of steel section is concerned, IS 800-2007 provides this table, and in this table you will find this information, that is the grade classification, the Indian standard confirming these grades, which is IS 2062, and these are the grades those are provided. And for these grades, some important information is also mentioned, right? I will be explaining you the utilization of all these things whenever we will be talking, or whenever we will be solving some numerical. But before that, just try to understand what is the exact meaning of these grades. So we slowly, what we have done, we have understood the background of IS 800. Then we came to the discussion related to different types of steel, shapes of steel, how the mild steel behaves. Mild steel behavior, just keep it in your mind. Then, based on the preparation or the production of steel, now let us try to understand what are the different grades of steel. तो यहाँ पे देखो क्या दिया है, कैपिटल E 165 ब्रैकेट में FE 290. What does these terms stand for? E stands for engineering steel. FE stands for iron, isn't it? Chemical name FE. Capital W stands for weldable. So, for example, this grade E250 Fe410W, capital W. W means these steels or these steel grades are weldable. So, structural steel you will find we will be making use of these three exclusively. Other steels, they are hard steels and the purposes are different. So we will be concentrating more on these three because we want the steel to be welded. Okay, they should be weldable. So for that, these grades are provided. So you can see, capital E, it stands for engineering steel. Fe, iron. Capital W, it stands for weldability. Then there are few more classifications for grades like capital A, B, and C. What does they stand for? Capital A stands for the structural steel. Those are subjected to normal conditions and those can be used for non-critical type of applications. Right? So just the common construction, residential, commercial, okay, not specific criteria is required. For that, we can certainly make use of this grade A. Then there is capital B, structural steel subjected to critical loading where temperature is greater than 0 degree. Brittle fracture may be there. Okay, so the critical loading may be comprising of your moving loads, just like the bridges. For that, but if the temperature is greater than 0 degree, for that only we can make use of this B. For C, structural steel subjected to critical plus impact loading and the temperature, if it is up to minus 40 degrees Celsius, then we can make use of this steel. So you can consider this to be the fittest one for all conditions. You can consider this, okay, except for the temperature, right? So depending on various situations, all these grades can be made use of. Pertaining to that, you will find yield stress value is given. Yield stress means the portion which I had shown you in the earlier slide. This is the yield. So since it is a mild steel has got two yield points. One is the upper yield point and another one is the lower yield point. For study purpose, the lower yield point is considered. So ये जो yield value यहाँ पे दिख रही है, that is the lower yield value. ठीक है? So these are the few advantages and disadvantages of the structural steel. We will summarize this so that we can go ahead and see what are the different other situations those can be explored. So what are the advantages? Steel members have high strength per unit weight. देखो अभी पूरा जो डिस्कशन हुआ उसमें आप लोगों ने एक ऑब्जर्व किया होगा that the steel members are actually made up of combination of very thin sheets. Cross sections आपने देखे, flanges, webs, all these components, although they are monolithic, but if you compare them, if you isolate them, then you will find that they are made up of, they are combination of thin sheets. Thickness is of the order of hardly 6 mm, 8 mm, 10 mm, 12 mm. Okay, these thicknesses are of that order. Highest you can say 20 mm. 2 centimeter कुछ भी नहीं है, isn't it? So all these members, they are made up of very thin plates, thin members. Okay, and because of which the steel members have high strength per unit weight. Weight is very less. You can take example of the staircase. I don't know how many of you have used the staircase of your first year building. वो पूरा steel structure है, if you observe. The plates which are over those stairs, those are of the order of 6 or 8 mm. First year department. Meshram madam. Oh. Okay, so those are very thin ones, and the amount of load it is carrying is quite high, right? So it is an advantage. Thus, a steel member of a very small section which has little self-weight is able to resist heavy loads. Being light, convenient, it can be conveniently handled and transported. You can imagine. Hence, prefabricated members can be frequently provided. Properly maintained steel structures have long life. Properties of steel mostly do not change with time. Steel being ductile doesn't fail suddenly, gives early evidences in the form of large deflections. The thing which we saw, see, we saw the neck formation, isn't it? So actually it gave some signal. It didn't break all of a sudden. So that is the property of the steel, that it being ductile, it will give some warning, initial warning, and it won't collapse suddenly. Modifications can be easily done in steel structures. So unlike the concrete, where if the structure it fails abruptly, then it is very difficult for the aggregates to combine and prepare new concrete and do its repairing. But over here in steel structure, if any member fails, because the connections they are generally made up of bolts, welds, those can be easily done. Fast construction and erection process is there. So construction compared to, because it doesn't require any kind of curing process. We don't have to wait for days and hours. No need. We can go on constructing multi-storied structures in within 1 day or so, if expertise are available. Okay? Then highest scrap value amongst all building materials. So the scrap value is quite good. Steel come. So those forms the advantages and very few disadvantages, like they are corrosive in nature, so maintenance is required every now and then. Painting is to be done. That is of that that you cannot call it as disadvantage. That you can say that it is a kind of precaution that has to be taken. Second, this may form a disadvantage. Fireproofing treatment is required and it is quite expensive. So this is a disadvantage. Nowadays, um, research is going on in order to provide some solution related to this expensive business. So hope so that the fireproofing treatment can be achieved with very small amount. That's what we will hope for. And but the advantages are quite high. So what needs to be remembered? It has got high strength per unit weight. Easy construction is possible. They are lightweight. They can be transported from one place to another. Prefabrication is quite possible, and owing to all these, and majorly the ductility, owing to all these advantages, I hope that in the coming days, all the structures will be made up of steel. Let's hope for the best. Okay. So in the next class, we will see the other properties related to steel, and we will also discuss about the design philosophies. I hope this is understood.
Yes.
Okay. So you people can leave. We will discuss the next part in the next class. Thank you.